And now we're going to begin and move on with the next session, which is with Franco Piva. And he's going to talk about BIM, DFMA, and the digital model. And it'll be very exciting. He is the Director and Mass Timber Specialist at Ergodomus Timber Engineering. And Franco has engineered more than 300 timber buildings and has been involved in several post-earthquake reconstruction projects in Italy. He's an expert in building physics and the design of buildings in earthquake zones. He firmly believes that the key words for the success of timber constructions in the future are detail studying, durability, prefabrication, engineering, and holistic approach. Franco's presentation today will shed light on the pivotal role architects and engineers play in the designing for manufacturing and assembly approach. And so with that, I'd love to have Franco join us, as we're so excited to have him here in Toronto, Canada. Thanks, Franco. I'm just going to switch presentations here for a second.
Okay, it works. Okay, good afternoon. Thank you very much for coming. Thank you very much to Rotoblas, Element 5 that who organized this great event. I was told that it is one of the largest events they organized in terms of attendees in the past few years, more than 100 people. So very good time for timber. And a few words about who I am, what we do in the company. The company Ergodomus was founded in 2007. So this year is 16 years. We are 16 years old, and in this period we worked in more than 18 different countries, engineering mass timber buildings, different sizes, small, large scale. Of course, in 2007, the world of timber was completely different, and I will show you later a slide explaining what I mean what I mean when I say that the world of timber was so different than as it is now. This is a map I must say I'm very proud of because it shows we started somewhere here in the middle of nowhere in the Alps. And we expanded quite a lot, engineering different projects, exploring different areas, and dealing with many different building codes, different workflows, different ways to use the digital files, different ways to use the digital models for the buildings. And in general, there is a big hype around the mass timber. And especially here in North America, every time I come here, every time I fly here, I see that there are new buildings, there are new challenges to face. The building codes are changing, and hopefully will be more. They will allow us to use more timber for the buildings also in the future, and they will not. I cannot say stop, but they will not slow down this process to move towards a more green economy and to use more sustainable materials for our buildings. So in this period, in the past years, we worked with many different actors, with many different players on the market. And one of the most important group is made by the producers because it forces us to push the boundaries and to arrive with our design up to LOD for 100, which means that our 3D models, the 3D models we share with our clients, the 3D models we prepare, are made, are so precise that we can create a CNC files with this, starting from this file. So Patrick this morning was talking a lot about the DFMA, the digitization of the building industry. And if you think to prepare so detailed drawings up to LOD for 100, it means that detailing will be one of the next keywords. DFMA is okay, designed for manufacturing and assembly, but we also need to keep in mind that everything is around the detailing. So I didn't know that we can use the word in English mass timber detailers, but That will be one very good sentence to use for the future. So this is me it was a few years ago when we engineered a very strange structure together with an architect from Nigeria. It is a floating structure in Venice. I don't know if someone of you went to Venice Biennale in 2016. There was a floating structure and we were the guys behind that project. It was very strange project, but it proved that you can do really not only small buildings, not only buildings with timber, but you can also do something very special. DFMA is our main service. I think that everything must be built around the DFMA when it comes to timber buildings, when it comes to the timber engineering, because once you have this holistic approach, once you take into considerations all the different aspects that are involved in a building, only in that case you can really design a building. You cannot be just a structural engineer, you cannot be just an acoustic or a mechanical, you cannot be just an architect. You have to have a very wide knowledge, and especially you have to keep all these things, all these different aspects in mind when you design the building. This is a very nice sentence of Einstein. I found it by coincidence a few months ago, and we have to face a lot of challenges. It was the first speaker about the LCA, the carbon emitted, the carbon stored in our building. We have now the chance to change. Nobody knows, I think, if it is too late, if it is not too late, but in any case, we can change, and as building industry, we can be part of this process, and we can bring our experience. We can timber can be can be part of the solution to solve the problem. And to show you, this is a slide I was talking at the beginning, to show you what happened in the past 25 years in the building industry. I always like to use this slide. It shows the maximum capacity. This not what they produced, but this is the sum of the maximum capacity of all the CLT factories all over the world. And you can see how the capacity changed from 1995, when 2 companies started the production in Europe. At that time it was crazy, but there were just 2 factories all over the world. Both of them exist, one with a different name, but they are still running, they are still producing CLT, especially one is one of the biggest at the moment, one of the biggest in the world. So in 1995, the production was about 25,000 cubic meters per year. And I started personally in 2003, which is here. And happy to say that tomorrow it will be exactly 20 years for me in the timber industry, because I started September 8th, 2003. So it is a good goal. I'm happy to be still here talking about timber. And also here there were only 2 producers, and the production was about 70,000 cubic meter per year maximum, the capacity. Look what happened 2010, 2015, and this year they expect that the maximum capacity, again, this is what we can call the press capacity of all the factories all over the world, will be almost 3 million of cubic meter, which is huge. 20 years ago, it was approximately 70,000, 80,000 maybe, something like that. And now we're talking about 3 million. I asked the University of Graz, who created this slide, if they have something to update, to see how they think the future will be, how the 2024, 2025 will be. Personally, I expect that for sure it will be more than 3 million. There is a lot of room still in the market. The demand is really high all over the world, not only in Europe, not only in North America. So I think that these numbers, this diagram will keep going up, and in the next few years it will be more than 3.5 millions of cubic meter. It is in metric, sorry, but imperial is very hard for me. I don't know, 3 millions in cubic feet. I have no idea. You can check, but it is a lot. It is really a lot of material. CLT, my idea, the mass timber in general, it is not just a material. It is not just timber. It is not just something we can use for our building. I really think that timber is a digital material. It is something we can quite easily use in our 3D model, in our digital model, and all these things together brought a big revolution in the market. So in the past 10, 15 years, we're getting more and more material with acronyms like BIM, DFMA, or different aspects like robotic prefabrication, computational design, off-site versus on-site. So combining all those things together, I believe that we can see DFMA as a new value engineering tool. Every time I have a meeting with a potential new client, it can be a builder, it can be an architect, it can be a developer. Guess what is the first question they come up with? What's the cost? Can we reduce the cost? Can we make timber the most cost-effective material to go for? Of course, we're all happy if we go for timber, if we use sustainable material, but at the end of the day, the decision, almost all the decision was driven by the money. So we need to find new ways to lower the cost and to go for timber. This is not easy. The connection design, the detailing again, this is something we need to consider. Not only as engineers, but also as architects, as industry. We have here many examples of great connections. Rotoblas is developing constantly. I don't know how many new connections every 2-3 years they develop. This helps to reduce the cost, and another thing, they help us to reduce the time for installation. If you go for a more expensive connection, but it takes 20 minutes instead of 1 hour to be installed, you save a lot of money. When you install a CLT element, you have to consider that 3 to 4 guys are involved, plus 1 crane. So if you multiply these numbers and you reduce by the time from 1 hour to 20 minutes, just changing the type of the connection you're using, you can save a lot of time. And if you multiply by 100, 3,000, 200, 300 beams, 300 columns, then it is a big saving at the end of the day when you evaluate, when you quote a cost for the building, for the structure. So I added just a few seconds before, a few minutes ago, I added a new word at the top, design and detailing. Thank you, Patrick, for manufacturing and assembly. I will work a bit more to see if we can find other words beginning with D, because I think that everything is around this acronym. We want to go for timber. We need to have this in mind. We need to design and to detail the project in a very good way. And to show you what I mean for holistic and what I mean for holistic and for detailing for DFMA, I made this short movie with my drone a few years ago. I was on the site, and I wanted to show that we need to raise our point of view. We cannot just look at our feet and say, okay, let's talk about the structure, let's talk about acoustic, that's it. No, we need to raise the point of view. We need to see how the site is. We need to know how big the crane is. We need to know if there are some limits for the trucks. When we work, for instance, on projects in Australia, we know that we always have to deal with the size of the container. They are 40 feet. They cannot be longer than that. Even if it is 40 feet plus 1 inch, the beam will be too big and you cannot be transported on a container. So once you have the global view, once you have the big picture of the project, then you can design the building and you can value engineer it using the tools we have like the DFMA. And this is a very nice picture I took from this artist. This is what happens in many, many cases. We design something, we dream this building, then there are the first step, we meet the client, then we prepare the final drawings. Here we could consider that we could be at level LOD 200, maybe LOD 300, but then on site you got this. I'm not saying that timber is solving all the problems, not at all. I was saying before, this year was so stressful for us for a couple of complicated projects that I told my colleagues, my business partner in Italy, I'm giving up. Stop, because there are so many problems. So I will not do that. But this is very frustrating when we see, because it means that there are so many problems between 1 and 4. So timber can help us. How can timber help us? Because timber can be seen as a digital material. So once we prepare the drawings, we are sure that we draw something and we get exactly that element on site. No surprise, at least for the structure, everything will be exactly as it was on the screen. So for those of you who was using the computer in the 90s, knows the acronym, what you draw is what you get, what you see is what you get. It was meant to say, you see something on your screen, you print it, and you get it on your laser printer exactly as it is on your screen. Now we can make the same thing in 3D. You draw something, you get it on site. I'm sure you're very familiar with the 3D printers. You can use Rhino, you can use the software you like. The most complicated part is to make the drawing of the element you want. To draw this octopus, for sure, it was a big effort. But now, once it is ready on your computer, a few steps, a few hours, and it is ready on the 3D printer. So we need to see all the buildings, all the structures as a digital model. It is something similar, in my opinion, to what happened in the Matrix movie. The people were seeing this, but behind this, there was a real world. There was a total real, semi-real world. And when I say the digital model, when I speak about the digital model, the IFC, the DFMA, etc., this is what I mean. The drawings prepared by the manufacturers, by us, or by the timber engineers in general, is an IFC model. And when you click on an element, the information you receive is not just, this is a timber element, stop. No, here you can read a lot of more information. You can see that this beam will arrive on the first truck. The grade, 28H, is the European grade. Glulam, the name of the producer, and the number, there will be a label somewhere in the column telling you that this is the label 11113. In our case, means block 1, level 1, element number 113. So you click on the element and you see all the information. And that column, which is very, very complex, I will show you later how the head of this, here it is. The head of the column has this shape because we need to create enough room for all the connections. There is a mix of custom and bespoke and standard connections. But the good Thing is that on site, this is what we receive. These columns are quite big, 60 by 60 centimeters. We're talking about an 8-story building in Denmark. It is an office building, and you see the shape of the head of the columns compared to the drawing. Exactly the same size. No matters how complex the detail is. The most complicated part is detailing, because behind this there is someone in the office spending hours and hours and hours to prepare the drawings, to be sure that the CNC machine will create that element as it was in the drawings. So sadly, in many cases, the time needed for the detailing is not considered, is not taken into account during the design process. I look at the Gantt diagram. They arrive here, LOD 200, 300. 2 months production drawings. No way. Not doable. Oh, disappeared my image. Not doable. You cannot do in such a short time. You need much more time for the detailing, for the connection design, optimization. Otherwise, it will not be the good result. So the production drawings are something similar to this. You need to add, to draw every single element. It's not enough to say slotted steel plate with 20 dowels. No, you have to draw every single dowel, one by one. You have to draw the steel plate. You have to consider the tolerance between steel and timber, timber to timber, timber to steel. All these things could be 0.5 millimeter, 1 millimeter, but you have to consider it, otherwise they will not assemble the element in the time they thought. I'm showing you now a few projects in the last minutes. I had a time of my presentation here, but it disappeared. I don't know, so I don't know exactly. Please. Okay, this is another interesting project we completed recently in Australia. A lot of timber trusses with these CLT panels to create a first level for the offices. So this company has the trucks and the machines on the ground level, and the offices on the first level. They wanted to have to hide as much as possible the connectors, the steel plates. So all the steel plates are completely hidden inside timber, but the bracings are visible. So we work a lot together with the architects to make them nicer, or try to do our best to make them nicer. But what they really appreciated was that we share the IFC file, so they could see how the building will be. So they received the first containers of the material, I guess, beginning of August, late July, and they will start the assembly of the first elements. Maybe they started this week, or they will start next week. Again, you receive this 3D model, and we are 100% sure that you will get this thing on site. It will nothing be of similar, a bit similar. It will be exactly what was on your computer, what was in the IFC model. And you, as a developer, builder, architect, whoever you are, you can just click on an element and you see who that element is. You can see all the information of that element without sending email, asking, calling, what is that? Is it CLT, 5-layer, 5-ply, 3-ply, 7-ply, etc.? You just open the IFC file and you click on it. You can open, you can import in ArchiCAD, Revit, Outline, SketchUp, Rhino, whatever. But you can see all the database connected to the 3D model. And you can implement all the information you want. How many minutes they need to install the element? What's the cost per cubic meter, per square meter, or per tons, per kilo, etc. You can implement in the description of the IFC file, of the IFC element, and with that information you can quite easily work on those numbers using Excel or another spreadsheet. A big difference, BIM versus BDM. Building information modeling is when we have all the information we need and we deliver the information they need. Building this information modeling is when this workflow doesn't work. And sadly, it happens quite often. They send you an IFC and they ask you, I want something like this, but a bit different, because can you please change the size of the beams or the inclination of the diagonal elements, etc. So we as designers need to learn how to wisely use all the digital tools we have. There are many, many digital tools on the market, and thanks to this, we can say that BIM plus timber has many advantages. You can control 100% of the process. Can you imagine you go with your iPad on site, you just click on an element, and you can compare if they install the element in the right position, at the right height, in the right location, using the right screws. Everything is implemented in the IFC file. So the control on site is quite easy because it is 100% digital. And again, the most complicated part is the drawing and not the production of the elements, the prefabrication of the element. Show you very quickly some pictures of some projects we completed in the past years. This is probably one of the most extreme ones. It is a canopy at the top of a skyscraper in Brisbane. They wanted to go for double curved timber element, glulam element. Not super sustainable, but sorry guys, but work is stopped. Okay. So we worked very hard in creating the 3D model in Rhino and the algorithms to create semi-automatically the drawings, the production drawings of the steel plates. Okay, and this is how this is a rendering on the left. Up to here is concrete, and from the street level is about 100 meters. And here you can see some pictures during the constructions. So they completed everything, and they've never called. So it means no news, good news. They completed, they sent an email. Everything is fine. We had some troubles, but nothing special. So it was very good. I was very nervous when they started to assemble the structure because the tolerances were so small, but it looks amazing now from inside. This is the project I was talking about. It is in Denmark. This is a picture we took this. It is a picture of this morning because there is a webcam, and you can see how they are assembling the building. So they completed just block 1 of 7, and it is level 1, 2, 3, 4, 5. So there will be, this tower will be like up to here, 8 levels, and then it is like, as you can see, from 8, 7, 6, 5, 4, 3, etc. levels. It will be one of the largest in Europe. We're talking about 300,000 square feet in total of CLT, and it is a hybrid structure. 4 concrete shafts, a lot of steel beams to have enough room for the mechanicals, and then timber and glulam for columns and beams. We received these pictures just yesterday or so. We pre-drilled all the holes. Well, we drove, and then there was a company pre-drilling all the holes in the glulam beam, so it would be easier for plumbing, HVAC ducts, etc., to be installed on site. This is another quite extreme project. It is in Singapore, and they will start the assembly next week. I'm going there to see to see it around the mid of October. Single curved elements, and they rented. Fun fact about this project: they rented an entire ship to transport these columns in one single element because they are 23, 25 meters longer. So they were too long for the container, and we worked together to decide how to transport the elements. We helped them also in this project to manage a little bit the logistic aspects to transport material from Europe to Singapore. Here you can see some more pictures. This is the digital model we prepared and sent to the client for the final approval. They receive the IFC file. They say, yes, green light, and then the production. Then we can send all the drawings to the production. But before, we always need to have the green light based on the IFC file. Well, these were the connections we developed using glued-in rods. There was a strict quality control to glue these elements off-site. This is a project here in Canada. We worked together with guys of Element 5. It is the TRCA office building. Our scope of work was, again, here, connection design and detailing. And these are just two screenshots of some drawings we prepared. These drawings show how complex is the design of the connection. We have tons of steel to design. Every single hole must be drawn. Every single aspect must be taken into account. And BIM here again was a powerful tool because there was a BIM manager merging together timber model, concrete model, steel model, and the 3D model from the mechanicals to know exactly where to add extra, where to pre-drill the holes in the beams and in the columns. The last project is this one, is in Norway, and it is the very first modular building for us we designed. They completed, there were super complex logistic aspects to manage, but they were not on us because all the modules were produced in Poland, transported to Norway, to Trondheim in this case, and then transported, special transport from the port to the site, and then installed in a very short time with the crane. These modules are not standard, sadly. Every module was a bit different. And they are like 4 meters, 4 meters 20 wide, 10 to 12 meters long, 3 to 3.5 meters high. They installed approximately 110 modules in just 13 working days, working on 2 shifts. All the modules were already, in all the modules, all the mechanicals were already pre-installed. So there were all the wires for electricity, pipes for hot and cold water, Ethernet cables, everything was already in there, and they had just to connect all these wires to the main cables, let's say, that were in the concrete shaft in the middle. That was the sequence they gave us. We go in this. The sequence would be this one because the connections we had to develop together with the company, completely new connections to connect the modules to the concrete shaft and the module to the next one, to the one on the left or on the right. It was a very complex project to work on. There were in total 4 towers, and they added extra 4 towers for another very similar project next, quite close to this one. And this is how the building looked like from outside. You could never see that, you could never say that it is a modular building, but they install the facade after they complete the installation of the different modules. I think that here in Norway, the weather condition can be quite extreme. Cold, rain, And in Trondheim, when they started the assembly, I think they had just like 4 or 5 hours daylight. It's quite up north. Okay, and this is really the last one. Is a project, is a super hybrid project. It is a headquarter of this company. It is located in Italy. And they decided to go for CLT only for the facade because there were so many holes. Each hole has a different shape. And CLT, we proved that CLT was the best solution to go for because it was light, first of all. And then it was quite easy to design all those holes and to create the files for the CNC machine. They wanted to have the holes in a specific position because each window can be painted with a different color. So when a client from Canada visits the company, he will find the Canadian flag on the facade. So all they wanted to have this pixel effect because they produce special printers, and they wanted to have this effect, this pixel effect on the facade. So they were very, they paid a lot of attention to the position and the size of each of these windows. It's okay. It's done. Thank you.
Thanks, Franco. So we have a few minutes for a Q&A, maybe about 5 minutes or so. If anyone has some questions, I'd like to ask to Franco. Someone up there, I believe, on the right by the.
Yeah, sure. I mean, I was just curious to know how that relationship was for yours and integrating with imports like Belgium here or overseas, where you do multiple prefab manufacturers. Is there a separate BIM owner? You mentioned pulling together that drama project. That to me seems like a really key piece of making that work well. I'm just curious to get thoughts on how you normally do that. What's the right way to do that?
Well, each project is different. Every time we have to change the workflow or to better understand who is the owner of the BIM model. So for the project in Canada, we were not in charge of the production drawings, of the 3D drawings, but there was a Element 5 prepared all the 3D model, and we were like supervising and telling them how the connections had to be made. In general, I see that the trend now on the market, based on what I see, is companies, developers and contractors are more and more using platforms like Procore, Dalux, or similar to collect all the files in the same position and to merge the files either in the platform or outside the platform using Navisworks, Solibri, or similar tools. But as you said, this is one of the key factors to make the project successfully happen. If there is no BIM management, if it is not clear who does what in this workflow, it is a big problem. And it is something we are experiencing in some projects. So you download the file. Is it the most updated one? Oh no, let me send you the new one. This is something we experience. It is not a perfect world, but.
And I asked because we tried this with computer software platforms and even explored some of the data Revit plugins as well. But surely a frustration because we're dying to hear the models, but either they can just see them or we can see theirs or something. And this one over. We're not all on one platform. There's so many tools and now we can see Revit and ArchiCAD. So I guess, I'd like to think that the .IC is solid for us, but in our experience, it's been
I don't know how many concrete engineers are here, but steel and timber can work together quite well. I know that in Toronto, concrete is the king, but the reason is that there are many software that allows you to use this technology in a very good way. You can share the files, you can export, you can merge the file, you can clash the detection, you can find all the clashes in a very short time. And you are sure that steel and timber elements will be on site with that shape. Concrete is a bit different. It is more plus minus a couple of centimeters, while with timber we consider plus minus 1.5 millimeters, plus minus 2 millimeters. I think that in the future there must be, these platforms are evolving quite fast, and I think that in the future they will help us to solve these problems. I hope, because at the moment it's a big headache for us as well. Yeah, it is a big headache. Yeah, I must say that. Yeah.
Maybe we can take one more question.
Yep.
Anyone else that would like to ask a question? Oh. Carol?
Thank you. I just had a question about the modular project. How far away from the job site was the modular fabrication done? That's one question I had, and then the second one was, well, because we hear all the time shipping error is a problem. And then the second question was, could you comment on the acoustic performance when you'd have a modular setup like that for residential?
On the project in Norway, the distance was, you consider Trondheim to Warsaw in Poland, more or less. So I guess 1,500 kilometers, more or less, I guess. But it was, there were different sequences, like a truck on the barge, and then on the port in Trondheim, and then on a truck again to the site.
And so the economics for that was all kind of...
They said yes, provided they were able to assemble the elements at least, I think the magic number was like 8 modules per day, 8 modules per shift. No, 8 modules during 2 shifts. So 4 modules per shift. And also, the labor cost is so high in Norway that they proved that it was still the best way to go.
So did you guys actually model the logistics of that assembly as well, like the truck, the crane?
No, it was the company, and each time they had to change the order. Last in, first out. It was every time last in, first out. Well, not every time, because sometimes it was first in, first out. It depends how you unload the barge, how you put the elements in the port. During the weekly meetings we had, they explained us a bit more about that, and it was so fascinating. Last in, first out the first time, maybe first in, first out the second time. It was very interesting. But that the company was, they could even customize the elements so highly that they could have one element painted in white and the other element inside painted in red. So the client could choose the colors, the type of the kitchen, and everything was already assembled inside. Kitchen furniture were already there from Poland. And it was a good project, a great project.
And so just the second part of that was the acoustic performance between units?
Yep.
The flanking?
There were some acoustic pad between the different modules in vertical to stop the vibration from one module to the other one. The good side is that was made for the impact sound. For the airborne sound, the situation is a bit better because you have the seating of the module and then air, and then the roof of the module below. So airborne sound is, I cannot say never a problem, but almost never a problem. They worked quite a lot on the impact sound using these acoustic mats. They were delivered by Rotoplas.
right away.
Awesome.
Yep.
Thank you.
Yep.
Thank you so much, Franco.
Okay.
Thank you so much, Franco, for joining us all the way from Italy. We're so glad to have you here at the conference.